Chapter 24 Probability. Second video. Sample space. The set which consists of all the possible outcomes of a random experiment is called its sample space. It means you should write all the possible outcomes as a set. It's usually denoted by capital S. First example, write the sample space of the experiment of observing the number which turns up when an unbiased cubic die with its faces numbered from 1 to 6 is rolled. Okay, it's so simple. We should write the sample space as a set. So the possible outcomes are 1, 2, 3, 4, 5 and 6 now. So capital S is equals to the set with the elements 1, 2, 3, 4, 5 and 6. You should write all the possible outcomes within a pair of curly brackets by putting comma sign to separate the elements. How many elements are there? 1, 2, 3, 4, 5, 6. So number of elements in the set is number of elements in the sample space is 6. In here we are not using the sign curl E to represent the sample space. If it is a universal set in sets, we are using the symbol curl E. But here its probability when we are doing a random experiment to represent the sample space, we are using capital S to represent the sample space. Second one, write the sample space of the experiment of tossing a coin and observing the side that turns up. What are the possible outcomes? Head and tail. So sample space is equals to the set with the elements head and tail. Here number of elements in the sample space is 2. Third one, write the sample space of the experiment of drawing a bead from a bag which contains 6 identical red beads and 4 blue beads marked R1, R2, R3, R4, R5, R6, B1, B2, B3 and B4 respectively. So it's very simple to write the sample space. Sample space is equals to the set with the elements R1, R2, R3, R4, R5, R6, B1, B2, B3 and B4. Number of elements in the sample space is 10. Number 4. Write the sample space of the experiment of recording the number on which the indicator which is fixed to the center of the disk falls when it is spun and allowed to stop freely. We know all the possible outcomes, so we should express it as a set. Sample space is equals to the set with the elements 1, 2, 3, 4, 5, 6, 7 and 8. Number of elements in the sample space is 8. Number 5. Write the sample space of the experiment of observing the number which charts the table when an unbiased tetrahedral die with its faces numbered from 1 to 4 is rolled. What are the possible outcomes? The unbiased tetrahedral die is numbered from 1 to 4. So, the possible outcomes are 1, 2, 3 and 4. So, we can represent the sample space as a set with the elements 1, 2, 3 and 4. Number of elements in the sample space is 4. Last example, there are 2 cards such that capital R is written on one side and capital Y is written on other side. The cards are tossed simultaneously and the letters turned up is recorded. Write the sample space of the experiment. Here two cards are tossed simultaneously, so what are the possible outcomes? It's a little bit different from the previous examples. Yeah, it can be both cards with the letter R or both cards with the letter Y or one card with R and another card with Y. Then first card with Y and second card with R. So these are the possible outcomes. When we are writing these possible outcomes, here you can see two cards here. So we can use parentheses. It means normal bracket to represent one outcome. Here you can see it. Sample space with the elements RR, RY, YR and YY. Here one outcome is represented by a parenthesis. So how many outcomes are there? There are only 4 outcomes in the sample space. So NS is equals to 4. Actually in here we can write events. As an example, both cards being letter R. Two cards with the different letters. So an event is a subset of the sample space of a random experiment. Do the activity number 2. To continue the lesson, you should watch the next video.